Welcome back to Foundations Tutoring. Today we're going to be covering the question, what is the integral of 3x squared plus 3x minus 1 divided by x cubed plus x? We're going to be using the method called partial fraction decomposition. And typically how partial fraction decomposition looks is that you'll have something like f of x is equal to p of x divided by q of x. And the reason why we use partial fraction decomposition is because it breaks up the fraction into easier fragments. For example, we'll have something like a over x plus b over x squared plus 1. And to be able to find the integral makes everything so much more easier. And let's just say, for example, we have a equal to 3 and b perhaps maybe equal to 2. Then we could have something like 3 over x plus 2 over x squared plus 1. And then finding the integral of that, we can immediately see that it would look something like ln of x 3 times ln of x. So that's the reason why we use partial fraction decomposition, to be able to break down an integral into easier fragments. So let's get started. So first we're going to be defining our variables. Let p of x equal to 3x squared plus 3x minus 1, where x is an element of real numbers. Remember when we spoke about partial fraction decomposition, f of x is defined as p of x divided by q of x, right? So this whole entire term would be p of x, and the bottom term would be q of x. So let's just define q of x. Q of x then is going to be x cubed plus x. And one of the things that we notice is that we can take out the x. So we can just say x is equal to x squared plus 1. If we take out the x, it's going to be x is equal to x squared plus 1. So let's write that down, where x is an element of real numbers. One of the things that we need to notice is that q of x is a denominator. We know that x cannot be equal to 0, or else this would not even be able to work. And so that's just one thing that we need to note. X cannot be equal to 0, because if it would be 0, then it would be undefined. Now we're going to say there exists. So this is the sign that I use to say that there exists unique real numbers. Just going to write number as a symbol. A, B, and C, such that p of x over q of x is going to be equal to a over x plus. Now let's just pause. Let's just take a moment to just analyze everything that we've written down. So there exists a unique real number, a, b, and c. Why am I saying this? Because we see that for p of x, the numerator, there are 3 terms. 1, 2, 3. And so our p of x needs to have 3 terms. However, when we look at the denominator, q of x, we only see 2 ways that we can be able to write this variable. We see x, and then we see x squared plus 1. So there is an imbalance. That's basically saying there's 3 variables at the top and then there's 2 variables at the bottom. So how can we be able to write this in a way that would be able to substitute or would be able to help with the fact that there are 3 variables as the numerator and then only 2 variables as the denominator? What would we do? So I would do b of x plus c divided by x squared plus 1, right? So that would make us cover both the numerator and the denominator. Basically what I'm saying is the denominator, q of x, has 2, x and x squared plus 1, right? And we say that the numerator has three variables: 3x squared, 3x, and minus 1. So what we can basically do is break that up to say, okay, I still have a, I still have bx, and I still have c, which would make that 3 in the numerator, and then at the denominator I would still have my two variables. Therefore, we can cross multiply. So we want to just keep the denominator the same, right? To say that x times x squared plus 1. But now I just want to combine everything. So I'll say a over x squared plus 1 plus bx plus c times x, right? So we're just going to be combining everything right now. And we can be able to cross multiply by saying a times x squared plus 1 would give us a plus x times bx plus c would be able to give us x times bx plus c, which would give us x times x squared plus 1. Perfect. And so now we see, okay, we've been able to write down p over x over q over x, which is basically f of x, but we're now able to write it using values a and bx plus c. This goes back to what we were saying in the beginning. When we use partial fraction decomposition, we basically want to substitute values in the end. So we want to make sure that we break down the fraction so it can be easy to work with, easy to be able to solve. And so, since we've cross multiplied and we've defined everything as f of x, now it's time to group it. So we can then multiply outwards by saying a x squared plus a plus x times bx plus x times c. So that would give us b x squared plus cx divided by q of x. So I'm just writing this in a simpler version. It's still okay if you write the actual q of x, which would be x times x squared plus 1, but I'm just writing q of x just to make things simpler and to be easy to read. Now we can be able to group them. We see x squared, so let's just group everything together. We're going to group the x squareds together. We're going to group the x's together and the constants together. So we'll say x squared a plus b plus, you can say x times c plus a divided by q of x. So now we've been able to break down the fraction, group everything. So we're going to move on to the next step. So I'm going to say p of x, well, before we even go back to that, we're going to say this would be able to be true if and only if p of x is going to be equal to x squared times a plus b plus xc, or cx plus a. So we're basically saying this is possible if and only if p of x is equal to that, which it indeed is. P of x is equal to this, and q of x is still equal to q of x. But that's just a condition that we wanted to write down. And so now we're going to say, so if and only if p of x is equal to that, so that now we can say a plus b is equal to. And let me explain this step, right? X squared matches with 3x squared. xc matches with 3x, and the constant, which is a, matches with -1. This is important because now we're going to be able to break these down to find the values, right? So we said x squared matches with 3, just like what we saw just now, that x squared matches with 3. Each variable here, right? So the 3 over here, the 3 over here, and the -1 there are going to go with corresponding values. And I'm just writing b and c hypothetically, but they go with the corresponding. So let's just say we have x squared a plus b. Then we know a plus b has to equal to 3, right? Since we're saying x squared a plus b, then we know that what times x squared is going to give us a plus b? 3, because we see the x squared there. So that's the same thing. We can also just say hypothetically that like b plus c is equal to 3x, right? Let's just say that there's like an x, b plus c. So then if I'm saying x times b plus c, that basically means b plus c has to equal to 3 to give us the x, right? 3x. And so we're going to do that. So let's go back to this. That's going to be 3. Since we know that x squared times a plus b is going to equal to 3x squared. So we know that a plus b has to equal to 3. So since we know that a plus b has to equal to 3, then we can go back and look at the term. X and c. We see x and 3. That means that c has to equal to 3, because if x of c, or let's just say c of x, is equal to 3 of x, then what does that mean? 3 is equal to c. So let's write that down. And then if we look at the remaining constant, a, we know that a would then have to equal to -1. So these all match with p of x, right? We've got the a plus b, we've got the c, and we've also got the a. So we're on the right track. So from here we know that a is equal to -1. And we know that a plus b is equal to 3. And since we know that a is equal to -1, then we can say -1 plus b is equal to 3, which would then give us b is equal to 3 plus 1, because we're moving this to the other side. So b would be equal to 4. And then we've seen that c is equal to 3. So now let's just look back at everything that we've done. We started off with the question, what is the integral of 3x squared plus 3x minus 1 divided by x cubed plus x? We broke it down. We said that this was q of x, and we broke it down and said it would be x squared plus 1. Then we see, okay, these are 2 ways that we can break this, but we have 3 variables at the top. So what did we do? We said a plus bx plus c, and then we divided it by x times x squared plus 1. Then we were able to find the variables, match them with the a plus b to be able to get our actual variables, which we're now going to substitute back into the equation, right? So remember, so we know that p over x divided by q over x is going to be equal to minus 1, because we know that a is equal to minus 1. And then we see over here that cx, we know that c would be 3, so that would be 3x. Let me write that down properly, 3x. And then we see that the constant a would be minus 1. So then we can say minus 1 divided by x plus, and remember, because we're going back to when we said that p of x over q of x is equal to a over x plus bx plus c. So we're substituting this back into this, right? Where we know that a is equal to minus 1, b would be equal to, let's see again, it was 4, and then c is equal to 3. So c would be equal to 3. So we're just substituting everything back into this, right, where we see this is going to be a over x and then bx plus c divided by x squared plus 1. And so we know that b is going to be 4x plus c, which is equal to 3, divided by x squared plus 1. That's perfect, because we know in the beginning that f of x is equal to p of x divided by q of x. And so we're finding the integral of this, which is f of x. And so this makes our life easier, because then we can be able to say, okay, we know that p of x divided by q of x is f of x, so we can just find the integral of everything. So the integral of minus 1 over x plus 4x plus 3 divided by x squared plus 1 dx. We're getting somewhere. So let's just break this up, because we see that there's a term we can say minus 1 over x plus, oh yeah, let's not forget the dx, plus 4x plus 3 divided by x squared plus 1 dx. Amazing, because we immediately see that we can say that this would be minus ln of x, right? Because we can take out the minus 1, and so it would be the integral of minus 1 over x, which would be equal to ln of x. But now we see this. This goes back to our functions. We know that these are the derivative of trig functions, right? So sine minus 1 of x, oh, let me write this properly, right? Sine minus 1 of x is literally the same thing as arc sine of x. So I'm going to use this format and say arc sine of x. So this is going to be very useful, because we already see something familiar. We see the x squared plus 1. And where else do we see the x squared plus 1? I see it here, right? X squared plus 1, or 1 plus x squared. So we see that that's going to be extremely useful for solving this integral. So let's solve this integral. The integral of 4x plus 3 over x squared plus 1 dx is the same as saying the integral 4x divided by x squared plus 1 plus 3 times x squared plus 1 d of x. This is important because we're breaking down this fraction once again, because we can say, we're basically saying x squared, the denominator, by the first term, and then the denominator by this term, is we keep the denominator the same, but we break up the numerator, because we see that there's a term here. We break it up to be able to do that. And so then we say, okay, we're going to say 4x over x squared plus 1 dx plus the integral of 3 over x squared plus 1 d of x. We can see that this would give us 3, because we can remove the 3 to say the integral of 1 over x squared plus 1 dx which would give us, if we remember, going back to the functions, this is going to give us arctan, because 1 over 1 plus x squared, 1 over 1 plus x squared. So that's going to give us 3 arctan of x. But over here, interestingly enough, we can say let u equal x squared plus 1, so the whole denominator, so that du is equal to 2x dx. And we know that if we make dx the subject of the formula, we would get dx is equal to du divided by, let me write that properly, du divided by 2x. And so if that's the case, we can say this would be the integral of 4x over u, and we already know that d of x is going to be equal to du divided by 2x. So we can say du divided by 2x. These two cancel each other out. So you're just going to get 4 over 2, which is 2. And we can take out the 2 so that we can be able to say 2, 1 over u du. So let's do that. I'm going to say the integral of 2, 1 over u du. And so we know that that's just going to be 2 ln of u. But now we know, okay, we're seeing u. Always remember, never forget to just keep it like this. Always remember to substitute the u back into where it belongs. So then we're going to say that's going to give us 2 times ln of x squared plus 1 plus 3 arctan of x, which we solved over here, arctan of x. Okay, so now let's just go back to the original question. And never forget this part, because remember we broke it up and then we broke this one up to get these values, right? Where we got the answer of 2 ln x squared plus 3 arctan of x. But that is not the complete answer. Never forget this part. Never forget the fact that we were here and then we did this and we broke it up into other two terms. Always remember that there was a minus ln of x. So the final answer, oh, let me write this in red. The final answer is going to be negative ln of x, from what we saw over here, plus 2 ln of x squared plus 1 plus 3 arctan of x plus c. That is the most important thing. And I'm not really sure if you can see it, so I'm just going to move it a little bit. Plus c. And that is the final answer. Thanks for watching.